So my name is Winfried Hensinger. I'm a professor of quantum technologies at the University of Sussex, and it's been for 20 years my dream to actually build a real-world quantum computer. And in 2018, we founded a company, Universal Quantum, and with a goal to actually build real-life quantum computers. And we founded this in 2018. We're still in the seed phase. We've did attract quite some venture capital, around 10 million, and probably attracted a total of 100 million in funding. And but before I'm going to tell you more about the company, I'm going to maybe tell you a little bit about what is actually quantum. And hands up, who's heard of quantum before, or quantum computing? Good, a few people, excellent. So quantum is very strange. So Einstein found it spooky. So in quantum theory, there's a phenomenon called superposition. It means you can actually be at two different places at the same time. So that's highly convenient. It doesn't really happen with people, but in a lab we can actually make that work with individual atoms. And then there's something even stranger than superposition, that is entanglement. And that's what Einstein referred to as spooky, because it's a very, very strange correlation that really can't be explained in any kind of intuitive fashion. And physicists for many years, including myself, did experiment over experiment trying to get our head around these very strange phenomena. But maybe around 10, 20 years ago, physicists thought maybe we can tame these very strange phenomena and build new technologies using these quantum phenomena. And there's a whole range of different quantum technologies. It ranges from quantum computers to sensors that are capable of detecting things that you cannot detect in any other way, whether that is pipes underground. And in fact, a lot of the building works are there because people don't know where these pipes are, and it's very difficult to detect exactly where they are. So that's really interesting application. Also imaging technologies to see things that you cannot see any other way. And so I've got here a little table that shows you some of the applications of quantum technologies. And as you can see, this ranges all the way from drug discovery to really changing the financial sector, to making fertilizer more efficient, saving 2% of the world's energy spent making fertilizer. So it's really, these applications range far and wide. And because of that, many countries have decided to really invest into what is really creating a whole new industry sector. And I've got a graph here just to show you. And I mean, one of the really amazing things here, and that's something really to be proud of, that UK has been playing a really, really pioneering role, and it's been one of the first countries to, in fact, really push quantum technologies. I've testified in multiple countries, in the White House, in the German Parliament, because the UK has done this so right that other countries are really imitating what we do here in the UK. And equally, that also means that there's a lot of investment from the private sector. There's an exponentially rising number of startups and a lot of private investment into really making this transition from quantum, from academic research into real-world technologies. And so what can actually a quantum computer really do? And in a very simple two-line explanation, it can solve certain problems where even the fastest supercomputer may take billions of years to solve. And if you're more mathematically minded, it changes the scaling of how long it will take to solve a certain problem. And these problems that can be solved on a quantum computer range from making new materials to creating pharmaceuticals much faster and at a much reduced cost, to understanding biological processes. And maybe one of the things which is really, really important is to understand other quantum systems. And the world around us is all quantum. And so essentially, if you can exactly simulate quantum dynamics, that gives rise to really, really powerful capability that enables you to really do step-changing things in nearly any industry sector. So now this is the good news. Here comes the bad news, and that is that actually every single quantum computer you can access or see in the world right now, the machines from IBM, Google, all of them work with around 100 bits. And unfortunately, a quantum computer with 100 bits can't do anything useful whatsoever. And so to summarize the entire field of quantum computing, there's not a single machine in the world right now that can actually do anything useful. So here you go. So the good news is the machines that are out there demonstrate that the very principles of a quantum computer do work, but there are way too few qubits in order to actually solve any practical problem. And so let me talk about who we are and what we do at Universal Quantum. So as I said, quantum computers have really a vast potential, but they cannot really realize this potential unless we can scale quantum computers from a handful of quantum bits to millions of quantum bits. So that means really you have to change very much the technology approach altogether in order to realize such a machine. And this is maybe a short summary of what we do at Universal Quantum. We have developed a very different approach. Other quantum computers need to cool to close to absolute zero, to minus 273 degrees Celsius to millikelvin temperature. We have an approach that works at room temperature with mild cooling. We use a new approach where we execute the calculations inside a quantum computer using voltages applied to a chip, where our competitors needed millions of laser beams aligned with the precision of the width of a human hair. So you can imagine that this is very difficult to scale a technology up like that. That's why we developed this alternative approach. We recently broke a world record in connecting multiple microchips together and connecting them and transferring quantum bits with tremendous speed and tremendous precision. And what we actually do, we construct and build quantum computers, and at the core of these quantum computers sit very sophisticated microchips, and we have a way to build them in such a way that it really scales to large qubit numbers. So as a company, we've, as I said, we're founded in 2018, and we've grown quite a bit. We were awarded a Business Startup Award from the Institute of Physics, and it makes me really proud being a physicist, obviously. Bloomberg identified us as one of the top 25 startups in the UK to watch, and maybe the most proudest thing personally for me is that we've been identified as one of the best places to work. And fundamentally, that's really most important, because it is really the people who make a difference, and we have an amazing company culture and worked really, really hard to make that happen. So following our seed phase, and we've raised some funding, we really were able to develop our technology, and as part of that, we found a lot of excitement, and following an extremely difficult and long-winded tender phase. You can imagine in Germany nothing is ever easy, and there's a lot of bureaucracy. After a very, very long process, we awarded one of the largest government quantum computing contracts ever made by the German Space Agency. So we're building now for the German Space Agency 2 quantum computers built on the technology I told you about, and it's a really, really exciting thing. So for us to be able to showcase this technology, work with users. We also work here in the UK with companies like Rolls-Royce and electronic companies, vacuum companies. We're really trying to establish in the wider region here a quantum Silicon Valley. And while it sounds a little bit mad, like you think, oh, how can you have in Brighton or London a Silicon Valley? It is actually true that here the UK is way over proportionally performing in quantum technologies. The research here is world leading. At Sussex, for example, we have a world leading center for quantum technologies. And so there's really opportunity to capitalize on the academic research and convert this in an industrial sector. And the government is supporting that with missions, with billions of pounds of investment. So this is really an exciting time. And so as a company, we've profited a lot from amazing investors. So starting, obviously, we are physicists. We were then lucky enough to have a really fantastic support system of investors in the seed phase. We are here based in Hayward's-Heath, in close to Brighton. We have a subsidiary in Germany, and we have also a small office in the US. And I'm just going to end my presentation by asking you a question. What do you think could be an unbelievably fast computer operating like any other technology, arguably executing its operations in parallel universes? What could that do? Thank you very much.